That's part of the story of how you
Yeah,
approach things. Sometimes you do things from scratch. Sometimes at first you kind of see what's out there, and then you decide to do from scratch. That was one of the boldest decisions I've seen, is both on the hardware and the software, to decide to eventually go from scratch. I thought, again, I was skeptical of whether that's going to be able to
sure.
work out, because it's such a difficult problem. And so it was an incredible journey. What I see now with everything, the hardware, the compute, the sensors, the things I maybe care and love about most is the stuff that Andrej Karpathy is leading with the data set selection, the whole data engine process, the neural network architectures, the way that's in the real world that network is tested, validated, all the different test sets, versus the ImageNet model of computer vision, like what's in academia is like real world artificial intelligence.
Yeah.
So, and
And Andre is awesome, and obviously plays an important role. But we have a lot of really talented people driving things. So, Ashok is actually the head of autopilot engineering. Andre is sort of director of
AI stuff. Yeah. So yeah, I'm aware that there's an incredible team of just a lot going on.
Yeah, just obviously people will give me too much credit, and they'll give Andre too much credit. So,
and people should realize how much is going on under the
it's just a lot of really talented people. The Tesla Autopilot AI team is extremely talented. It's like some of the smartest people in the world. So yeah, we're getting it done.
What are some insights you've gained over those 5-6 years of autopilot about the problem of autonomous driving? So you leaped in having some sort of first principles kinds of intuitions, but nobody knows how difficult the problem.
Yeah, I thought the self-driving problem would be hard, but it was harder than I thought. It's not like I thought it would be easy. I thought it would be very hard, but it was actually way harder than even that. So, I mean, what it comes down to at the end of the day is, to solve self-driving, you have to solve. You basically need to recreate what humans do to drive, which is humans drive with optical sensors, eyes, and biological neural nets. And so, in order to that's how the entire road system is designed to work, with basically passive optical and neural nets, biologically. And now that we need to, for full self-driving to work, we have to recreate that in digital form. So we have to, that means cameras with advanced neural nets in silicon form, and then it will obviously solve for full self-driving. That's the only way. I don't think there's any other way.
But the question is, what aspects of human nature do you have to encode into the machine, right? So you have to solve the perception problem, like detect, and then you first realize what is the perception problem for driving, like all the kinds of things you have to be able to see. Like what do we even look at when we drive? There's I just recently heard Andre talked about at MIT about like car doors. I think it was the world's greatest talk of all time about car doors.
Yeah.
The fine details of car doors. Like what is even an open car door, man? So like the ontology of that's a perception problem. We humans solve that perception problem, and Tesla has to solve that problem. And then there's the control and the planning coupled with the perception. You have to figure out like what's involved in driving, like especially in all the different edge cases. And then I mean, maybe you can comment on this. How much game theoretic kind of stuff needs to be involved, at a 4-way stop sign? As humans, when we drive, our actions affect the world. Like,
sure,
it changes how others behave. Most autonomous driving, you're usually just responding to the scene, as opposed to like really asserting yourself in the scene. Do you think?
I think these. So actually, I think these sort of control logic conundrums are not the hard part. Let's see.
What do you think is the hard part in this whole beautiful, complex problem?
So it's a lot of freaking software, man. A lot of smart lines of code. For sure, in order to have create an accurate vector space. So like if you're coming from image space, which is like this flow of photons, going to the cameras, and and then so you have this massive bit stream in image space, and then you have to